Hello students, today I'll start with the laboratory preparation of hydrogen. Today I'll do the laboratory preparation as well as the industrial preparation, which is the Bosch process. Okay, let's start with the laboratory preparation. I'll show you the arrangement in short. This is a flat bottomed flask. The mouth of the flask is made airtight with a cork. There are two holes in the cork. Okay, don't ignore this portion because this is just a collection of HCl. Look at this part. Zinc in the form of granules is placed at the flat bottom flask. Then this is known as thistle funnel and this is the delivery tube. This is known as thistle funnel. Through this thistle funnel, dilute HCl or dilute HSO4 is added to the zinc granules slowly. And as soon as the reaction occurs with the zinc granules, you can see bubbles appearing in the acid medium. These bubbles afterwards will form brisk effervescence, which will be the hydrogen gas that is prepared in the medium. That hydrogen gas will pass through this delivery tube and will be collected by the downward displacement of water. Now let's come to the reaction. Zinc reacts with dilute HCl forming zinc chloride and hydrogen. Okay, here instead of hydrochloric acid, sulfuric acid can also be used. But remember, it should be dilute. Here by mistake I have written that 2. Please ignore that part. Okay. So zinc will react with dilute sulfuric acid to give ZnSO4 plus H2. So zinc will react with both sulfuric and hydrochloric acid in the dilute condition to form the respective salts, and along with that hydrogen gas is liberated. This hydrogen gas is then collected by the downward displacement of water. This is the laboratory preparation of hydrogen. Now I will come to certain factors which are important for you to know. These granulated zinc means the zinc granules can contain many impurities. Certain impurities can act as positive catalysts. They can improve the rate of the reaction, but some impurities are there which can poison the reaction, and in that case the impurities which are not important for this reaction, they have to be removed. That is, the pure hydrogen gas can be obtained. For obtaining this pure hydrogen gas, from the hydrogen gas the impurities have to be removed. So after preparation of this hydrogen gas is collected and then it is passed through various washer bottles. There are 3 washer bottles and one one tube which has a shape of U. So the first washer bottle consists of silver nitrate. What will silver nitrate do? Silver nitrate will absorb arsine and phosphine impurities. The second washer bottle contains lead nitrate. What will lead nitrate do? Lead nitrate will absorb hydrogen sulfide. The third washer bottle contains KOH. Now what will KOH do? It will absorb carbon dioxide, nitrogen dioxide and sulfur dioxide present in the hydrogen. Next is the tube in the shape of U. It consists of anhydrous CaCl2, that is anhydrous calcium chloride. What will this do? This will absorb the moisture from the hydrogen. So the purification unit is completed. Now I'll come to the precautions. What precautions have to be taken? Number one is that the entire setup has to be airtight. Now why it has to be airtight? Because hydrogen forms an explosive mixture with air. So the entire setup has to be airtight. Number two, no flames should be present around the apparatus because hydrogen is an inflammable gas. Next is that the end of this thistle funnel should dip below the acid. Why? So that the gases which are formed cannot escape through this thistle funnel. If it is dipped below the acid, then the mouth will be filled with the acid and the gases will not be able to escape through this thistle funnel. Okay, these are the precautions which you must take while preparing hydrogen in the laboratory. Okay, then I'll come to another point, which is that how is this collected? This is collected by the downward displacement of water. Why? Because this is lighter than air, so it cannot be collected by the upward displacement of air, and it is almost insoluble in water, so it is collected by the downward displacement of water. The next point is that why granulated zinc is taken. Why not molten zinc? The reason behind it is that granulated zinc may contain certain positive impurities which I was telling you before. They may contain certain impurities which can act as positive catalysts, thereby favoring the reaction by a catalyzing action. So granulated zinc is used instead of molten zinc. This is all about the laboratory preparation of hydrogen. Now I'll come to the industrial preparation of hydrogen, which has a name, Bosch process. Bosch process. It has 3 different steps. The first step is production of water gas. How is it produced? Coke. Coke reacts with steam. (1000°C) to form water gas. And this is an endothermic reaction, so heat is absorbed. Okay, this is the first process, production of water gas. The next process is reduction of steam to hydrogen by carbon monoxide. How is it done? This water gas reacts with steam. In this case, you know, excess steam is used. Temperature used is 450 degrees Celsius. Catalyst used is Fe2O3 and promoter chromium oxide. What will be the reaction now? But this was an endothermic reaction, but this is an exothermic reaction. Here heat is released. This is how excess steam is reduced to hydrogen by the help of water gas. For writing water gas, we always have to write this third bracket under CO and H2. The third step is formation, or you can say separation of carbon monoxide and carbon dioxide which were unreacted from the hydrogen. So, separation of unreacted carbon monoxide and carbon dioxide from hydrogen. Carbon dioxide can be removed by passing through potassium hydroxide. What will be the reaction? Okay, this is how carbon dioxide is removed by forming potassium carbonate. Next, how carbon monoxide is removed? By passing through ammoniacal solution of cuprous chloride. This will form an addition product. And carbon monoxide will be removed from the medium. Okay, this is the Bosch process. There are 3 steps: production of water gas, next is reduction of steam to hydrogen, and separation of unreacted carbon dioxide, carbon monoxide from the hydrogen. Basically purification of hydrogen. So this is Bosch process or industrial process by which hydrogen is prepared. Okay, now I will come to 3 other smaller techniques by which hydrogen can be prepared. First is electrolysis of acidified water. Electrolysis of acidified water. Acidified water, if electric current is passed, will form hydrogen and oxygen. This you all know the entire electrolysis of acidified water. Next is from natural gas. Methane, on reacting with steam at 800 degrees Celsius using catalyst nickel, will give carbon monoxide and along with that hydrogen. Here also carbon monoxide is removed from hydrogen by addition of ammoniacal cuprous chloride solution. And the last process of preparation of hydrogen is from calcium hydride. Calcium hydride reacts with water to give calcium hydroxide and hydrogen. Okay, so this is how hydrogen is prepared generally from metals, then in the laboratory, then industrially, and then finally 3 other processes, casual processes you can say, through which hydrogen can be prepared. So in the next video I'll start with the uses of hydrogen, and then I'll conclude the chapter by the redox reactions. Thank you.